Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Muhammad Abdul. Here I will present my presentation project about classification handwritten letter using HOG feature extraction with the classifier is support vector machine or SVM. So things first we need to do here is we need to load the dataset, and before we load the dataset we will load the library first, such as Pandas for the data manipulation, and then NumPy for the computation, Matplotlib for the visualization, and then HOG for the feature extraction, and lastly the label binarizer for the pre-processing labels. After we load the library, so we will load the dataset, EMNIST dataset from the CSV file here. Notice here the header value given is none because the data have no column name. And then after we load the dataset here, then we will separate the features and the labels from the original database. So the trained image will take all the columns except the first column, which is on the original dataset. It is remains the pixel values, and then the trained labels here will take only for the first column, which is on the original dataset. It will remains the labels. And then look at here, the shape here. It is 88,800 image and then 784 pixel each, so it is fit to 28 times 28 resolution. And then here I am testing to visualize the image of index 3, which we can see here it is handwritten letter of O, and then when I check the labels here it given letters of O. And then I am trying to using the HOG feature extraction for this image. So next we will use this feature value here from the HOG parameters. In this HOG feature I using the default parameter here, so the orientation we use 9, pixel per cells is 8.8, and then cells per block 2.2, and then the visualize we set it to 2, and the block norm we use here is L2, and here we're gonna take this value later. So we can see here the shape for the feature is 144, and then now we're gonna move to the sampling section here. First we need to make the data frame. This is to make the sampling process is easier. So after making the temporary data frame, now we are going to sampling 500 for each classes now using group by dot sample function, and then for the random step we use 42 for the reproducibility. And then after the sampling process, we're going to separate against the features and the labels, and then we can see here the data here, all given samples has 500 for each classes. So now the dataset given was perfectly balanced. And now we are going to the next step, is the pre-processing all the image with HOG feature extraction. And then things we need to do first here is we need to load another library. So we are using new library dataset from the Scikit-learn. It is used for making and templates, a database templates. And after that, this is I make some temporary variables to make the next step is easier. As you can see here, this feature shape we have got before, and then the same for the trained image sample. And after that, now we are going to make a new dataset, a new variable for saving the dataset later using make classification. And now for the we are going to extract all the image using HOG feature extraction, and then put it into the templates that we have made before. This is this template, and this process. Oh, This process using the same parameters like image that I used for the HOG feature extraction before. I'm just using the same parameters, the default parameters, and then this process, this is just an optional. So I want to save my HOG feature extraction into my folder named HOG datasets. And now we're going to jump to the label preprocessing. Here we will convert the categorical label into one hot encoding label using label binarizer. We can see here the result after the preprocessing labels. The it turns the labels into one array, and then we can see here the the original value of this train one hot index of the 1000 is 3, but after the label binarizer encode, we can see here from index 0, 1, and 2, in index of the 2, the value will be given 1 and others will be given 0. Okay, now we are going to move into the classification process using SVM. Again, like uh, the same step before, so we need to load another library again here. So we use SVC from the Scikit-learn.svm, and then we use leave one out for the evaluation model from the Scikit-learn.model selection. After we load the library, and then here we are going to initialize the SVM classifier model. Uh, Here after I'm doing research, so I will use the SVC kernel model of RBF, and then the C parameter is 10 and random step I use is 42. After we made the SVM model, now we are going to set up the LOOCV evaluation and then the list for saving the result. And now we are going to the main process. This is the LOOCV evaluation loop. So in here, the LOOCV process for each data for the train, it will be 12,999, and then for the test, have it is one sample to be used. So this process is the most computationally expensive. Like we can see here, my loop, this loop the evaluation process made give me about 14 hours to finish it. And then after that, I made uh, I convert the prediction result into the NumPy arrays. This is for the evaluation. This process just for making the next step is easier. And now we are going to the last process in this step. So we are going to do the evaluation matrix here, and like the same before. So we need to load another library again to do this process, such as confusion matrix, accuracy score, precision score, recall score, and then lastly the F1 score from the scalar.matrix. After we load the library, now we are going to calculate the matrix here. We are calculate the accuracy, the precision, the recall, the F1, and then the confusion matrix. And then after that, we are going to display all the results here. And this is the result we got here. We can see here uh, all the we can see here I can say this result was excellent because all the confusion metric score is above 87% here. So it means by means the model is working good enough for the 26 classes.